Did you know that everything we thought we understood about the largest, most magnificent planet in our solar system was fundamentally transformed the moment we dared to look beneath its veil of clouds? For centuries, Jupiter has hung in the night sky as a beacon of planetary majesty, a colossal gas giant that has sculpted the very architecture of our solar system. It stands out in the cosmic dark as a protective older sibling, its immense gravitational embrace drawing in stray comets and wandering debris. Yet, despite its overwhelming prominence and the countless nights spent gazing through telescopes from our pale blue dot, the true, profound nature of what lies deep within those swirling, turbulent cloud bands remained one of the most beautiful mysteries of modern science. That is, until the arrival of a breathtakingly bold human endeavor, a brilliantly engineered emissary from Earth known as Juno. Launched across the vast, silent ocean of interplanetary space, the Juno mission was conceived with a singular, deeply profound objective: to descend into the perilous heart of Jupiter and read the hidden record of its origins, uncovering the intricate physics of its internal structure and the wildly complex dynamics of its atmosphere. After a solitary, 5-year journey soaring through the unforgiving, freezing vacuum, Juno arrived at a world that is as hostile as it is beautiful. Jupiter is surrounded by an environment of trapped radiation that would instantly tear apart the delicate circuitry of ordinary electronics. These radiation belts are a relentless storm of high-energy particles, accelerated to a fraction of the speed of light. It is, quite simply, the most treacherous, energetic radiation environment anywhere in our solar system. To survive this deadly, invisible tempest, Juno was armed with a magnificent vault of solid titanium, a protective shell allowing our instruments to plunge closer to the gas giant than humanity has ever dared before. What Juno revealed as it began its elegant, sweeping orbital dives immediately shattered our long-held models of how giant planets are born. Before this historic voyage, we held a relatively simple picture in our minds. We believed Jupiter possessed a dense, solid core of rock and ice, perhaps 10 times the mass of the Earth, or perhaps no solid core at all. However, Juno's delicate measurements of Jupiter's gravitational field revealed something far more exotic and unexpected. Instead of a distinct, solid sphere resting at the center, Jupiter possesses a vast, diluted, fuzzy core. This beautifully complex region extends outward across nearly half of the planet's radius. It is a mesmerizing, churning mixture of heavy elements, crushed rock, and a bizarre state of matter known as liquid metallic hydrogen, all dissolving and blending seamlessly into the lighter gases above. To explain this fractured heart, we must look back billions of years to a violent, chaotic solar system, where a colossal, catastrophic collision with a massive planetary embryo shattered Jupiter's original core, leaving behind the glorious, mixed interior we see today. As Juno continued its majestic dance around the giant, it turned its sensors toward a force of nature that defines Jupiter, its unfathomably powerful magnetic field. If human eyes were sensitive to this invisible, magnetic architecture, we would look up into the night sky and see a glowing structure dwarfing the full moon. But Juno showed us that this field is far more asymmetric and intricate than we ever imagined. The vast planetary dynamo generating this force does not operate deep within a central core, as it does here on Earth. Instead, it is born in a swirling, electrically conductive ocean of liquid metallic hydrogen much closer to the surface. This creates an invisible shield 20,000 times stronger than Earth's, featuring a profound, localized magnetic anomaly near the equator that we call the Great Blue Spot. This staggering magnetic power is the engine behind one of the most awe-inspiring sights in the solar system, Jupiter's spectacular auroras. While our northern lights are painted by the solar wind, Jupiter's auroras are a self-sustaining spectacle of staggering energy. The rapid spin of this enormous world, combined with volcanic material continuously expelled from its tormented moon Io, creates a relentless, high-energy particle accelerator in the vacuum of space. These particles cascade down into the polar regions, illuminating the Jovian atmosphere with glowing, ethereal rings of ultraviolet light, powered by electrical potentials that challenge the very limits of our understanding of space plasma physics. And then, there is the legendary Great Red Spot. Juno's microwave eyes finally allowed us to see that this iconic storm is no mere surface blemish. It is a towering, colossal pillar of churning gas plunging hundreds of miles deep, rooted in the primordial, internal heat of the planet itself. With every graceful orbit, Juno peels back the layers of this magnificent giant, revealing not just a striped sphere, but a brilliantly complex world that compels us to rewrite the story of our cosmic origins. As the magnificent Juno mission extended far beyond its initial design, the scientists back on Earth realized they possessed a profound opportunity to do far more than just map the great gas giant. By making precise, elegant adjustments to Juno's sweeping, highly elliptical orbit, they transformed this solitary explorer into a surveyor of entire alien worlds, embarking on a series of daring encounters with Jupiter's fascinating entourage of moons. First among these was Ganymede, a world of such staggering proportions that it holds the title of the largest moon in the solar system. In fact, it is larger than the planet Mercury itself. It is a profoundly unique celestial body, the only moon we know of that generates its own internal magnetic field. As Juno swept gracefully past Ganymede, its cameras captured awe-inspiring, intricate details of a deeply scarred and shattered terrain, where ancient, dark impact craters are intertwined with bright, fractured icy ridges. Juno even recorded the haunting, ethereal radio waves generated by the complex magnetic dance between Ganymede and Jupiter, offering us a beautiful, eerie symphony of the cosmos. Not long after, Juno cast its inquisitive gaze upon Europa, an exquisitely smooth, icy sphere that stands as one of the most profoundly important locations in our quest to answer that eternal question: are we alone in the universe? Beneath a fractured, frozen crust of solid water ice, Europa conceals a vast, silent, and incredibly deep liquid water ocean. This lightless, salty abyss holds more than twice the total volume of water found in all the oceans of our Earth combined. Juno skimmed incredibly close to this fractured shell, hunting for the faint signatures of geysers erupting into the freezing void. The stunning, high-resolution topographical maps it returned to Earth reveal a chaotic, breathtakingly beautiful landscape of shifting ice blocks. This precious data will be the guiding light for our future missions explicitly designed to dive deeper into the profound, biological potential of this hidden, subterranean ocean. But perhaps the most dramatically violent and visually spectacular encounters were with Io. This is a tortured, agonizing world, locked in a relentless, gravitational tug-of-war between the overwhelming mass of Jupiter and the rhythmic pull of its sister moons. The ceaseless tidal friction physically kneads and warps the solid rock of the moon, generating unimaginable internal heat. The result is the most violently volcanic landscape in the entire solar system. Juno captured spectacular, glowing images of colossal volcanic plumes erupting hundreds of miles outward into the stark, black vacuum of space. By peering through the cold darkness of Io's night side with its infrared eyes, Juno revealed a hellish, mesmerizing world dotted with intensely glowing lakes of molten silicate magma. It is a beautiful, terrifying illustration of the fundamental laws of gravity continuously tearing a world apart and remaking it anew. When Juno inevitably turned its lenses back toward the extreme polar extremities of Jupiter itself, it uncovered meteorological phenomena that are nothing short of astonishing. Before we sent this robotic emissary, human eyes had never truly looked down upon the planet's poles. When we finally did, the familiar, elegant bands of horizontally flowing clouds were entirely absent. Instead, we were greeted by a mesmerizing tapestry of enormous, densely packed cyclones. At the North Pole, a colossal central vortex is locked in a permanent, intricately stable geometric pattern, surrounded by 8 massive storms forming a perfect octagon. At the South Pole, an equally profound pentagonal arrangement endures. These monstrous tempests, each vast enough to swallow entire continents, grind endlessly against one another in a chaotic, swirling ballet of atmospheric fluid dynamics, yet, miraculously, the underlying physics prevents them from ever merging into a single, chaotic storm. Juno has also unraveled a beautiful mystery surrounding the deep chemistry of Jupiter. High in the turbulent, freezing altitudes of the atmosphere, it detected violent, localized electrical storms. These bursts of shallow lightning occur in regions so profoundly cold that pure water should instantly freeze solid. The exquisite solution to this puzzle lies in the presence of ammonia gas, acting as a natural cosmic antifreeze. It beautifully disrupts the freezing process, melting the water ice to create a slushy, violent concoction that generates intense electrical friction, raining down heavy, ammonia-rich hailstones known as mushballs into the dark depths below. Eventually, the spectacular voyage of discovery must come to an end. When its reserves of fuel are finally exhausted, Juno will perform one last, poetic act of service. It will intentionally plunge into the crushing depths of Jupiter's atmosphere, burning up as a brilliant, artificial shooting star to ensure that the pristine, life-harboring oceans of Europa remain forever uncontaminated by earthly microbes. Until that profound finale, Juno remains our greatest explorer of the outer dark. If you found this cosmic journey through the wonders of Jupiter as breathtaking as I do, please hit that subscribe button, leave a like, and let us know in the comments which of these magnificent moons we should explore next.